Attenuated total reflection, as I've repeatedly said in these videos, is the most popular of the techniques, and you're shortly to see why, because it's also very, very easy to use. We're looking here to use the built-in ATR, which is built right into the cover of the Thermoscientific Nicolay IS50 FTIR spectrometer. I also showed earlier an accessory which has removable crystals. This one's built in. This is a diamond ATR, and I'm just going to run a variety of samples on it to show you the simplicity with which you can run it. Let's have a look at the computer for a moment. I've got it set up just to run simply with using the built-in detector. There's a detector built right in underneath the crystal there, so we have no problem with that. I'm just going to collect 10 scans because it's very quick, get me in and out, but I'm actually going to be doing most of the experiments in what's called preview mode. The first thing I'm going to do is collect a background, so I need to get the signal due to the diamond itself. What you're looking at here, you see these three large bands, this one, and this one in the middle. Those are absorptions due to the diamond itself. Those are vibrations of the diamond. But you see, in the regions we're interested in out on both sides, it's very clean. So let's go ahead and collect that, let it collect. And as soon as it's done collecting, I'm going to start running samples. And the first one I'm going to do is just my loyalty card here from Red Robin, just to see what that polymer is. So we'll go ahead and collect that. We'll get rid of it off the screen. We don't need to see that. And then we'll go ahead and start collecting samples. So now it's in what's called preview mode. So it's just collecting single scan after single scan. I'm going to take the card, and if I place it on the crystal and push down with my finger, you see I don't get any signal. That's not enough pressure or force down on the sample. So now I'm going to use the pressure anvil, and when it clicks, you see, boom, there's my spectrum. That's how easy it is. Slide it in and run. If I want to run a powder, here I have some granulated powder that I ran up. So I'll just take a little bit of the powder. I don't need much. Put it just on the diamond. Bring my anvil in. You notice there's no signal yet until I actually push it with the anvil. And as soon as the anvil comes in contact, I get this great big signal off of it. Very easy to run the powders. Now I want to do a brief little experiment for you where I will run two liquids and we'll look at the difference between the two. Let's clean those powders off. So I've run now the credit card and I've run a powder. Let's now run a liquid. So I'll start with this liquid first. And you see I've done everything in preview mode so far. I haven't actually collected data. I've just been letting it preview. Now I'm going to actually collect data. So I only need a little tiny amount of sample. So we'll put that on there. And that is the spectrum due to the water. You can see there are really three bands present in it. This large absorption at the low frequency, this one right here, which is your bending mode of the molecule, and then we have the stretching of the molecule. So those are three different vibrations, very intense vibrations of water. So we'll keep that one. Let's look at the whole spectrum. Double click, Control F. So now we're looking at the entire spectrum. Now all I'm going to do is simply wipe off that liquid, and I'm going to take this, which is a soda sample. Again, I only need a tiny amount of sample. So I'm going to place that on there. Okay. And I've got the soda on there now. Start the spectrum, let it collect. And if you look at the screen, you'll see that it's very similar, but there are also some subtle differences. This peak, and this peak we've already seen, but as you can see, there's some other things. Let's zoom in on those here in a moment and see what can be seen. So there are the two spectra overlaid right on each other in common scale. Let's zoom just on that part, which is where the interest is, and again, common scale. When you do that, or we can offset them just a little bit. It'd be easier to see if we offset them just a little bit. You can see here, this peak is repeated in both. Well, that's the water, and the majority of the soda is water. But you also see all of these peaks and a sharp little peak right here. Those peaks to the right there, at the low frequency, those are sugar peaks. That's from the sugar that's in the soda. And this sharp little peak right here is due to the dissolved carbon dioxide, the carbonic acid or CO2 that's in there, H2CO3, that's in the solution. So you get this small little peak here. So, very briefly and very quickly, that's why ATR is such a popular technique. It's so easy to use. I have run in the span of this video not only multiple different samples, but different kinds of samples. A solid piece of plastic, powder, liquids, run them all, no problem. This is why ATR is so popular. So once again, attenuated total reflectance, the important thing, being in contact with that surface, push down hard and be in good contact with the surface and you'll get a good signal. So attenuated total reflection, use it, it's a great tool.